All right, we're going to do a couple examples of integrals of the natural exponential function. The natural exponential function is, of course, e to the x. And we know the derivative of e to the x is e to the x. So that it follows that the integral of e to the x dx is e to the x plus c, of course. So the way this plays out when you have an integral is you might have something like e to the 5x or something like that. Right? I'm going to do something different. Let's do e to the, let's do pi x, okay, dx. Well, the integral of e to the x, and really when you see that e to the x, that x could be any function. So, derivative of e to a function is e to the function, right? So derivative of e to the x is e to the x, and derivative of e to the pi x is e to the pi x. And we'll get our plus c, but what we need to do is make sure that this works. And what we have to do is take the derivative of this function and make sure that that's equal to this function. And of course, the derivative of e to the pi x is e to the pi x, so that's good. But then we would multiply by the derivative of this inside function, which would be pi. And there's no pi out here. If we wanted to get that derivative, we could put the pi there. And in order to do that, we'd have to divide by pi, and which we can do out there. So basically, we need a 1 over pi here to cancel out the pi that's going to come out of that chain rule from the derivative of the inside. So this is our final answer now. Okay? Pretty simple when you just have e to the e to a constant times x. The answer is just going to be, the integral is going to be 1 over the constant times that original function again. Let's do something a little bit tougher. Let's do something like the integral of secant squared x e to the tangent x dx. Okay. Well, we have an e to a function, right? The integral is always going to include e to that function. Okay. So we can just know that that's going to be there. And then we have to make sure that the derivative of what we have here is going to be equal to the integrand that we started with, right? Is the derivative of e to the tangent x equal to secant squared x e to the tangent x? And it is, because, the e to the tangent x stays and times the derivative of tangent x, which is secant squared x. Now, this gets a little trickier when there's a constant involved, because the constant is going to come out. If this was like tangent 2x or something, you'd have to divide by 2 and that sort of thing. So be careful with that. There's one more kind of problem that you'll see, which involves chain rule, stuff like 5 plus 2 e to the 3x to the 6th. And then we'll have an e to the 3x out here. Okay. The main thing here is that you have a chain rule, a composite function, where you have this quantity, right, to the 6th. And the quantity to the 6th is the outside function. Whenever you have a composite function, you have to remember the inside stays the same. So the answer to this is going to have the 5 plus 2 e to the 3x. When we take the antiderivative, the integral, the power goes up, so that's going to go to a 7, and we divide by that new power. Okay, now the question is, if we take the derivative of what we just did, do we get that original integrand? And of course, you get this quantity to the 6th again, right? Because the 7 becomes a 6 and comes down in front, and it's going to cancel with the 1/6, with the 1/7. So that works. And then out pops the derivative of the inside, right? So the derivative of 2 e to the 3x is 6 e to the 3x. We have the e to the 3x, but we don't have the 6, so we need to basically multiply by 1/6 to cancel that out. And so the final answer is 1 over 42. 5 plus 2 e to the 3x to the 7th plus c. All right. So there you go. Hope that helps. Good luck on the homework.